Mark Phillips from ELB Engineering Services. My role in the project was as lead civil structural engineer, and my official title at the company is GM Engineering. So during the course of the project, I assumed the role, the function of looking after the other disciplines such as mechanical, EC&I and process. Okay, the project was a greenfields zinc processing plant where we took from the mining contractor, we would take ore from the mining contractor into front-end crushing, from crushing onto stockpile, from stockpile feed into the processing plant with ball mill, sag mill, flotation, thickeners and so on. So the scope of the steel work per se was by its nature heavy mining related structures, heavy industrial structures. There was materials handling, as in feed from the crusher to the stockpile, from the stockpile out to the mills. The mill building itself is serviced by crane, EOT, electric overhead traveling crane, and the flotation part of the plant is all supported on structural steel work as well. It's cascading vessels and so on. It's not a traditional flotation plant. It's first of its kind technology in this country, developed by Woodgrove in Canada, and it's a much smaller, tighter, compact flotation plant, which is all supported on structural steelwork, which is unconventional. Ordinarily, the traditional flotation plants are supported on stepped concrete. Well, this gave us an opportunity to use structural steelwork for the whole lot. Then there were a number of other structures, such as the admin buildings and change houses and laboratory, which we also did in structural steel. That's the light, cold rolled space frame type of stuff. The biggest challenge is that we would not be able to fabricate any of our steelwork close to the site. So all of our fabrication was carried out either in Gauteng or down in Cape Town, and it was brought by road transport to site. There's very limited site, being Aggeneys, which is between Uppington and Springbok. And although there is some industry developed in Springbok particularly, which services existing mining operations there, there's very limited capacity for carrying out structural steelwork fabrication. So everything that we did was manufactured 2 days drive away from the site. So we approached it with the idea that we were going to fabricate as much as possible and assemble as much as possible in the fab shops, deliver it to site, where it would be taken off trucks and simply placed onto the structures where it needed to be. Because it's a mine, you're working under mines health and safety, it's very, very onerous in terms of its health and safety requirements. And you want to minimize the number of people that you have on site. They're expensive. You want to minimize your craneage, and you want to minimize your work at heights. So from the outset, we said as much as possible in the fab shops, as little as possible on site itself. Now, a number of years back, we took very seriously, under direction of Institute and John of CADEX, to convert to a TECLA standard for our detailing. But we took it a step further in that we do the full package, production down to production of drawings on TECLA. So we stay very much in control of that entire process, and it helps us in terms of scheduling deliveries, keeping track of items and parts and so on, knowing exactly where everything is, but having the detailers work hand in hand with the engineers, not only the structural engineers, but the civil engineers. The greatest thing we achieved is that there was zero error between structural and civil. Every single structure fitted its holding down bolt perfectly. There was no concrete that had to be taken down. There's no holding down bolt that was out of place. And the way that we built up the entire model of the entire plant, so it's huge, was that we would take the Tekla 3D structures and we would put them on top of 3D civils. Every single one was placed there to make sure there were zero interface errors. Any of that type of thing leads to so much rework on site, and that's so costly. We made very, very sure we had zero error there. There was also very tight control of structural steelwork fabrication, and then we would assemble as much as possible here. Yes, what it means when you're putting that onto a low bed truck and taking off to site, you're transporting a lot of void between the steel. It would be a lot more economical if we were just transport and logistics to have a disassembled, bolted structures, all packed, and then they can assemble and bolt and put it up on site. And it worked very, very much in our favor to have as much as possible welded, as much as possible pre-assembled, simply deliver it to site, lift it off, and place it. And that philosophy worked like a dream. There was no rework, there was no demolish and reconstruct and holding down bolts out of position, and there was very, very little requirement for people to work at heights. And that minimized time on site, and it minimized the number of experienced people, qualified people that you would have to have for working on heights. And also our site workshops landed up being very small. We avoided reinforced concrete wherever we could in favor of steel work. We could control it a lot better. Our QC control in Gauteng works and in Cape Town works a lot easier from our head office to do that than if it were being done on site. So we could control the fabrication of steelwork and then make the erection of that steelwork very, very much simpler. And it has huge benefits which outweigh reinforced concrete if you're building in remote areas. The thing that we're proud of is it was a huge project to take on, having just implemented Tekla in the office. It was a challenge to find the right people to be able to do it. Just in that, the difference between somebody who knows how to draw and somebody who knows what to draw. Just because you know how Tekla works doesn't make you a detailer. Okay, and we went through a lot of people who said, yes, I know how to use Tekla, and they did to a point, but couldn't actually turn it into detail. So you've got to be a detailer to be able to produce final Tekla details. That was one of the challenges, in that we hadn't been running it for very long, and we were learning as we were going along. And then it was a case of screening out those who weren't actually detailers and up to the job of taking Tekla to final detail. So it was almost a baptism of fire, really, doing that to yourself. But it worked so well. That is one of the things that we are proud of. What we did is identify and work with selected contractors, fabricators, who would take our Tekla models directly and prepare to work with them, and not to do the detailing themselves. Now that also meant sitting with them beforehand, before we start the final production of drawings and particularly connection details. Seeing what their workshop's equipped for and how they do certain things. Because each fabricator actually likes his in-house detailers to detail connections their way. So we've done a lot of work with selected, chosen contractors who prepared to work that way with us. They were very nervous, they were skeptical, they wanted to do it themselves until they see it working. And it does work. We detail the way that they fabricate, and each one's subtly different. But then they would get the full detailing package from us, and they would have to do nothing but feed it through their machines, print out the assemblies, and then start assembling on that. So that's another thing to be proud of, really, is to take that function away from fabricators, but still keep them confident that what you're going to give them is a productive and efficient way of constructing and fabricating. And then as I said, in terms of the erection of steelwork, is that although we were transporting large pieces and it made our transport costs a lot higher, having assembled as much as possible. And for instance, conveyor gantries would have their walkways fitted and handrails and the idler frames. Not the idlers themselves, but the idler frames would be on. And that made site time, it reduced site time, reduced working at height, reduced the number of people, and it's very expensive to keep staff on site. That's really the thing that's had the biggest impact, positive impact on the project.